An oscilloscope is a general-purpose device for capturing and viewing one or more electrical signals and measuring their characteristics. There are numerous makes and models of oscilloscope. Each has its own dedicated set of functions and controls, but they all share certain features in common. The basic tools for capturing, viewing, and measuring one or more signals. They can be used for viewing both analog and digital signals and viewing digital data packets. Oscilloscopes can be set to single shot to capture an individual event, or set to run for capturing repeating or continuous signals. A typical application might be to measure vibrations by using a transducer to convert mechanical motion into a voltage which is displayed on the scope. Modern oscilloscopes contain a processor which can have dedicated memory for storing readings. Oscilloscopes with dedicated memory retain all their settings between sessions, so it's important to remember to reset the device using the default setup button before starting to use it. Oscilloscopes typically have 2 or more channels. Each channel is used to look at a different signal. The function and submenus for each channel are selected by pressing the number button below the vertical adjustment dials. Each channel has a BNC bayonet Neil-Conselman connector which attaches to the equipment being tested. Oscilloscopes have many different functions depending on the model, but all oscilloscopes share the same basic controls. The vertical and horizontal adjustment dials change how the signal is shown on the display. In simple terms, they're the zoom controls. The vertical adjustment dial changes the value for volts per division on the vertical axis of the display, so that the signal can be seen more clearly when measurements are made. The vertical position dial adjusts where the ground baseline is on the display. For normal measurements, this can be left in the center position, but if necessary, the ground can be moved in relation to the screen to allow for more vertical adjustment of a signal. It can also be used to move channels to superimpose them. The horizontal adjustment dial changes the time range per horizontal division for the display. Again, this is used to zoom in on the signal until it can be clearly seen. The horizontal position dial adds a delay into the signal so that it moves left and right along the horizontal scale. This can be used when comparing two signals so that they can be aligned. Most digital oscilloscopes have an automatic setup button which adjusts the voltage and time scales to zoom in on the signal. Whilst this function is useful, it shouldn't be relied on, as the calibration will adjust to the peak-to-peak signal that the software identifies. This might just be part of a signal with recognizable variance, and the main signal could be ignored. For this reason, it's always recommended to start with a default setup and zoom into the signal. The next common feature to oscilloscopes is the trigger adjustment. Basic triggering is used in 2 ways. It can be used to synchronize a repeating signal so that it appears static. The trigger dial changes the value on the upward or downward slope of the signal that is used to synchronize it to the display. In this example, a simple capacitor and switch circuit has 2 probes attached so that the voltage can be measured across the capacitor and across the switch as it's closed. When the voltage across the switch exceeds the trigger point, 0 volts, the oscilloscope starts capturing the signal. Another feature common to oscilloscopes is called coupling. AC coupling removes any DC component from the signal so that only the AC component is measured. Direct coupling, DC, shows both AC and DC components.